Inshallah, in today's class, we are going to continue the Laplace transformation. The problems based on multiplication by t. Now, let me first understand the methods and questions. Whenever you see the question in which some function is multiplied by t, some function is multiplied by t or t square or whatever t, then when the function is multiplied by t or t square some function, then we have to use the method of multiplication by t. So let me first understand what is the method here. You see here, suppose you are having some function multiplied by t, some function multiplied by t or t square or t cube, whatever it is, function multiplied by t or the powers of t, multiples of t. So how to start? First we have to leave this t, should not take t. First you find the Laplace of the other function, Laplace of the other function. Suppose this is capital F of s. So when we multiplied with t, we have to use this formula, minus 1 power 1 d by ds of the other function's Laplace. If we are multiplying by t square, then we have to use minus 1 power t square d square by ds square of f of s. Similarly for cube, for power, for whatever, general formula is Laplace of t power n is minus 1 power n d power n by ds power n into f of s. So this method is called method of multiplication by t. Multiplication by t. So let me do 1-2 questions based on these methods. So I'm starting with the easy question. You see here, first what is here? First we are having Laplace of t into cos t. How we can understand, how we can recognize this method? When we are multiplying some function with t, then you lift it, you just take the other function cos t, you find the Laplace of this. Laplace of cos at is s by s square plus a square, s by s square plus cos at. A is 1 here, 1 square will be 1. So you suppose this as f of s, capital F of s, let equals to s by s square plus 1. So when you multiply it with t, we have to use the formula. Okay, let me see here just now. Now see, I'm multiplying this. Now you take the formula. What is the formula? Laplace of t into f of t equals to minus 1 power 1 d by ds of f of s. So let me use this formula here. So Laplace of t into cos t equals to minus 1 power 1 d by ds of f of s is the Laplace of this function. This is s by s square plus 1. So let me solve this one. You see here, now we have to differentiate this. We know d by dx of u by v, d by dx of u by v is v d by dx of u, v d by dx of u minus u d by dx of v by v square. So this is the formula we have to use when we are dividing something. Minus 1 power 1 is minus. Now u by v, we have to start with v. This is v into d by dx of u, d by dx of x is 1. Similarly s will be 1. V d by dx of u minus u means s d by dx of v, d by dx of v. S square will be 2s, constant is 0, divided by v square means s square plus 1 whole square. Let me continue this one minus. So you see s square into 1, s square, minus 2s square will be minus s square plus 1 into 1 is 1 divided by s square plus 1 whole square. The last step. Now let you multiply this minus into minus plus, this will become minus. So this will be s square minus 1 by s square plus 1 whole square. So this is the first question. Now let me try for the second question. Let me try for the second question. See here, in the second question we are having t squared. That means we have to differentiate 2 times. See here. So what is the second question here? The second question is Laplace of, is here Laplace of t squared sine t. So how to start? First we have to find the Laplace of, you remove this t square, first you find the Laplace of sine t. Laplace of sine at is a by, a is 1 here, sine at, a is 1 by s square plus 1 square 1. You suppose this as f capital F of s, 1 by s square plus 1. Now see here, when we add this t square, so we have to use this formula t square f of t. So this formula will be minus 1 power 2 d square by ds square f of s. Okay, just now we have seen here, watch carefully, when we are multiplying with t, we have to use this formula. When we are multiplying by t square, we have to use this formula. So now let me write the value of f of s. So I am writing here minus 1 square will be plus 1. So what is left? D square by ds square of f of s is 1 by s square plus 1. D square by ds square we can write like this: d by ds of 1 by s square plus 1. Now watch carefully. First let we differentiate this one. Again we have to differentiate. We have to differentiate two times. Now first we differentiate the internal term. We cannot use u by v because this is not variable. This is constant 1. You see here how to solve. I will give an example. Suppose we are having d by dx of 1 by x. This will be minus 1 by x square. D by dx of 1 by x is minus 1 by x square. First thing. Suppose you are having like this: d by dx of 1 by 1 plus x square. This you have to differentiate two times. First you suppose this as 1 by x. 1 by x will be minus 1 by x square whole square. 1 by x is minus 1 by x square. Again you have to differentiate this. 1 is constant 0, but differentiation of x square is 2x, so you will get 2x here. So this is the method of differentiating. Now again I will explain you. You see here this outer ds you write as it is. Now d by dx of 1 by x is minus 1 by x square, means s square plus 1 whole square. Again internal differentiation, s square with 2s. This is constant 2s. You do one thing, you take out minus 2 outside. So if you take minus 2 outside, what is left? D by ds of s by s square plus 1 whole square. Now again we have to differentiate u by v. U by v is v d by dx of u minus u d by dx of v by v square. I'm writing minus 2 as it is. How to start? V. V means s square plus 1 whole square. V d by dx of u. D by dx of s will be 1. D by dx of x is 1. In the same way this will be 1 minus v d by dx of u minus u means s into d by dx of v. When you differentiate this, we have to differentiate like this. You see, suppose d by dx of x square plus 1 whole square. We have to differentiate two times. First, you see this, suppose this as x square. X square is 2x, so 2 into x square plus 1. Again, internal differentiation. X square is 2x. This is constant, so we get 2x here. So again, you see here. Again, I will explain here. D by ds of v means this one. X square is 2x, so you write 2 into s square plus 1 into again internal differentiation, s square is 2s, constant is 0, so we'll get 2s here, 2s. Now denominator v square, already we are having one square here, s square plus 1 whole. This is v, again square means v power 4. So let me do one thing, you take common from this 2, s square plus 1, s square plus 1, so we can take minus 2 into s square plus 1 common here. So whole square, no, we have taken 1 will be left here, s square plus 1. Now you see here we have taken common s square plus 1. What is left? 2 2s of 4, s into s square minus 4s square divided by what we are having here, s square plus 1 whole power, sorry, here it is 2, 2 2s of 4. Now see here, let me cancel this one. If you cancel this, you left with 3. Now last step, s square minus 4s square is minus 3 square, minus into minus plus. I'm taking this minus inside, so 2 into was once more minus 4 square plus 1 minus 3, minus into minus plus 3s square, my plus into minus minus 1. I'll take multiplied minus inside. Okay, now what is left here? Here it is left with s square plus 1 whole cube, s square plus 1 whole cube. Now let me do the remaining question, third question. Now see the third question, we are having three multiples, three terms, sine 2t e power 4t. First let me find this Laplace. Again, when we have to add this, we have to go into first principle, which we already have done in the last class. When we go here, we have to use first principle. Again, multiplication of t. So we have to solve this question with three methods. First start, let me start with sine of 2t. Sine of 80 is a by s square plus a square. 2 square is 4. Let me denote this with capital F of s equals to 2 by s square plus 4. First step. Now for second step, we have to use Laplace method of first principle. What is the first principle? Laplace of e power at. This is the first principle. F of t equals to f of s minus e. In place of s here, we have to write s minus e. what is s minus, let me continue, f of s minus, what is a here? A is the power of t. What is the power of t here? Power of t is 4, f of 4, s minus 4. So let me write this one. Now Laplace of e power 4t sine 2t equals to f of s minus 4. In this we have to write in place of s as s minus 4. So 2 divided by, in place of s minus 4 whole square plus 4. Let me expand this one. This is 2 divided by a minus b whole square is a square minus 2. 2 4s are 8 into s, 8s plus 4 square 16. 16 plus 4 is 20. So therefore, now the second step is finished. E power 4t sine 2t equals to 2 divided by s square minus 4 to the 8s. Sorry, this is I think 8s. 8s plus 20. Let me suppose this as g of s, because now one more method we have to do. Now we have to multiply with t. So if we multiply with the t, already we have suppose f of s is here, if g of, suppose this is g of t. So what is the formula of when we multiplied with t? When we multiplied with the t, the formula is minus 1 power 1 d by ds of g of s. So in this way, let me do Laplace of t into g of t is, what is g of t? This one, e power 4t sine 2t equals to, now let me use the formula, minus 1 power 1 is minus 1 into d by ds of 2 divided by s square minus 8s plus 20. Now let it continue. This minus 1 power 1. This is d by dx of u. You cannot use u by b because we don't have constant here. We suppose this as 1 by x. Just now in the previous question we have seen d by dx of 1 by x. You take 2 outside of this. Now 1 is left here. Taken 2 outside. So this will be minus 2. Now d by dx of 1 by x is minus 1 by x square. Minus 1 by x square means this is completely x. So x square, again internal differential you have to do. D by dx of x square is 2x, so this will be 2s minus d by dx of s is 1. 1 into 8 is 8. So let me do this last step. Minus into 1 is plus. You take 2 common from here. 2 into 2 will become 4 into, if you take 2 common here, it is left with s minus 4 divided by, in the denominator, s square minus 8s plus 20 whole square. So these are the few questions we have done based on multiplication of t. In the same way, let me do few questions based on division of t, division by t. Now see here, next questions based on division by t. Whenever we see there is a division by t, we have to use this method, division by t. So first you see here, suppose if Laplace of f of t is f of s, then Laplace of f of t by t, whenever we divide by t, we have to use this one, integration s to infinity, integration s to infinity f of s ds, integration s to infinity f of s ds. So I am doing two questions here. Now watch carefully. Now the first question, 1 minus cos 80 by t. The examiner will not tell, we have to understand the method by looking here. Now division by t, just now we have seen how to start division by t. You remove this, first you don't take t here. First you find the Laplace of 1 minus cos 80. So this formula is, Laplace of 1 is 1 by s. Laplace of cos is s by s square plus a square. So you denote this as capital F of s. So what is the formula for division by t? Just now we have seen. So when we use this formula, Laplace of f of t by t, this formula is integration s to infinity f of s ds. In the same way, Laplace of f of t is, f of t we are having this one, 1 minus cos 80 by t. This formula will be s to infinity f of s. F of s is this 1 by s minus s by s square plus a square ds. Now the next step, how to solve. You see here, there are few steps we have to see. First thing is very important thing here. You see here, this question is a little bit carefully we have to solve. Suppose there is a formula we are having, integration of f dash x by f of x. So this will be log of mod f of x integration of f dash x and f of x by f of x. Okay, now you see here integration we are having s by s square plus a square ds. Let I'm showing this separately. Okay, we can do here. You see here integration of 1 by x is directly log x. We don't have to fear about this. Integration of 1 by x is log x. Integration of 1 by x, we know this is log x. So this is finished. Here you see if you differentiate s square you will get 2s. You are having s here. If you have 2 here, this will be differentiation of this function. We can use this formula f dash x by f of x. You want 2 here. To get 2 here, you have to multiply with 2 and you have to divide with 2. You have to multiply with 2 and you have to divide with 2. So watch carefully. Now this will become the formula f dash s by f of x. F dash x by f of x. I'm writing like this 1 by 2. F dash x by f of x we can write log of mod f of x. These are the formulas of integrations. You must know the basics of integrations. Otherwise, the engineering mathematics you feel very difficult. If you want to have these formulas, you go and enter second year. First part, I have wrote all the formulas there. Enter first year, that is 11th class. You see in my uh, playlist, you go in playlist, enter second year, integrations first part. If you go in integrations first part, you can have all the formulas of integrations and differentiations. Okay, so now we got this formulas f dash x by f of x is log of mod f of x. Log of mod f of x. So we can use this one. So the integration of this will be 1 by 2. I am continuing here. You see here. Now integration of 1 by x is log x. So this will be log of mod s minus integration of f dash x by f of x. We have solved this one. 1 by 2 log of mod s square plus a square. Now after integration we have to use the limits here, s to infinity, s to infinity. Now see here, once more we have to do, let you do one thing, you take the LCM. If you take LCM, this 2 will come here, this will be like this, 2 log s minus log of s square plus a square divided by 2 s to infinity. There is a formula we are having, log a minus log b. This will be log of a by b. This will be log of a by b. You take out this 2 constant, sorry, 1 by 2. First you take 2 from here. If you take 2 from here, this will become the power of s. This 2 if you take from here, take out from here, it will be log of s square. Now log a minus log b is log of a by b. S square by s square plus a square s to infinity. Now watch carefully. We cannot do directly this one. We cannot do directly this one. Because if you go directly, this infinity, if you substitute, this will become infinity by infinity not defined. So we have to go in method of limits. What is the method? You have to first take s square constant, s square will get cancelled. Then we can substitute the values. No, let me do this method by using the concept of limits. Log of s square. First you have to take this s square constant. If you take s square constant, it will be 1 by a square by s square s to infinity. Because if you directly substitute this infinity by infinity, not different. Now this infinity s square get cancelled. Now you substitute the upper limit. Upper limit means in place of infinity s. Sorry, infinity. In place of s, infinity. Lower limit means same. So let me continue here. 1 by 2 into, I am substituting upper limit. Log of 1 by 1 plus a square by infinity, upper limit, minus lower limit means in place of s, s only, 1 by 1 plus a square by s square. What is the method for definite integrations? Upper limit means in place of s, infinity, minus lower limit means in place of s, s only. You see here, a square by infinity, any number by infinity is 0. 0 plus 1 is 1, log 1. We know that log 1 is 0, log 1 is 0. So this is 1 by 2 into 0 minus. Watch carefully. If you again you take LCM, s square into 1, s square. This s square will go up, log of, it will be like this, s square by s square plus a square. Now the last step, leave this 0 here. Now if you interchange this numerator denominator, this minus will become plus. So we can live here 1 by 2 log of, if you bring this denominator into numerator and numerator into denominator, this minus will become plus. This is a formula. s square plus a square by s square. So this is the next question. Let me do one more question. Now to reduce the length of the video, time of the video, I have done this question in short. Okay, I will explain you. You see, we have three terms, three functions: sine a t, e power minus t, then division by t. So start with sine a t. Laplace of sine a t is a by s square plus s square. Suppose this f of s. Now when we multiply e power minus t. We know, just now we had done the formula. What is f of s minus a? In this, in place of this, we have to write s minus a. In this function f of s, we have to write s minus a. Just now we have done s minus a is the power of t. A is minus 1. So minus 1 is plus 1. S minus a is minus 1, minus 1 is plus 1 whole square. Don't expand this. This will become the formula. You just note this as g of s. Now when we divide this with, when we divide this with t, we know the formula. What is the formula here? S to infinity g of s ds. S to infinity g of s is this one. This is, you see here, if you take out a outside, suppose you take out a, you take it outside. Suppose this is a, this is 1. This is that formula. 1 by x square plus a square is 1 by a tan inverse x by a. You have to know this formulas. 1 by x square plus a square is 1 by a tan inverse. Now for this, you can directly use the formula. 1 by x square plus a square. 1 by x square plus a square is 1 by a, this a as it is, tan inverse x by a. This is x, s plus 1 by a. Whenever you integrate, you have to write the limits here, s to infinity. Whenever you integrate, use the integration formula, you have to write the limits here. Now this a will cancel. What is the formula here? Upper limit minus lower limit. Upper limit means in place of s, infinity. Lower limit means in place of s only. So if you keep s in place of s, infinity, infinity plus any number division by any number, infinity remains infinity only. So this will be tan inverse infinity upper limit, tan inverse infinity upper limit, minus tan inverse lower limit s only same. Tan inverse infinity is but nothing but 90 degrees, that is pi by 2. Pi by 2 minus tan inverse s plus 1 by, we can leave here, but there is a formula we are having, inverse trigonometry. Tan inverse x plus cot inverse x is pi by 2. So cot inverse x will be pi by 2 minus tan inverse x. So pi by 2 minus tan inverse x can be written as cot inverse x. Pi by 2 minus tan inverse x can be written as cot inverse x. So we have done two methods here in the integrations, in Laplace transformations. So in the next class, inshallah, we are going to continue the questions based on, inshallah, inverse Laplace transformations. In the next class, inshallah, we are going to do questions based on inverse Laplace transformation.